Welcome to my presentation on Functional Scala today. I will try to introduce you to few concepts that will essentially make your code better. The presentation that I will give is more for an everyday user or everyday engineer that just needs to make his code more safer and more bulletproof for the real world. And to really get my message across, I need you to first take a really deep and really good look into your application. And I want you to think about your applications as this set of onions, if you like, and just like take one of those applications and slice it and look into the core of it. And if you start looking into the core of your application, you might start crying, but in a while you will also start to see that your application is built into different layers, if you want. And on the surface and the outside, you have layers that kind of protect your inner core, your inner business logic. And if you put more effort into defining more rigorous rules, into trying to define more protection around this core, you can have better business logic within, you will have less code within, you will have less problems down the road. And the fact is that you will be protected from a lot of these annoyances down the road. And it's a good reminder to think about this in this way, because the outside world is a dangerous place, and there are users that will interact with your application in various ways, and they can introduce a lot of damage to your systems. So for this talk, again, just think about how to protect your core and what techniques can we actually use in order to achieve that. So I will, through this talk, I'll try to show you this thing. And we have this hypothetical example where we have an application that has to deal with configuration. So this is like every standard web application that you worked on in the last couple of years or decades probably has some way of introducing the configuration to your application. And usually a lot of things depend on your configuration. So this is a very good starting point where you want to make things more rigorous, where you want to validate how these things integrate, and you want to make sure that everything is safe. And in the real world, you will actually encounter a lot of applications that look like this. So in this case, we have one type class, which is called config. It has an endpoint URL, it has a port, and we then have a configuration object where we try to read these variables from the environment, and then the rest of the system taps into that. Nothing really dramatic. You will see this in standard applications whenever you look into it. Now, if we try to run this application without ever checking the documentation and trying to understand what it does, we will get this really nasty application. And as a user of this application, we first encounter this and we instantly have a problem that we don't know where exactly this error came from. And we don't know like what was set, what was not set, what was actually the input that was emitted to the system, what we actually forgot to configure and how, right? So if you start thinking about this, right, what would be a normal way of how to fix this? You would probably read the documentation and you would try to set some of the variables by yourself, and then you would try to run it again. And in this case, for example, we try to just configure the port variable, rerun our example, and on the surface, this example runs and everything is peachy, and the world moves on and everything is good. However, right, at some point, people will try to build upon the code that you actually built. So in this case, somebody built this potato web service that actually interacts with your configuration. And they will just assume that the config layer that you build will be safe enough and solid enough that they can actually achieve these things. And when they will actually run the application with the configuration that you prepared, they will get another exception. And this one is going to be probably even harder to debug. And we don't know exactly if this is a problem inside the potato service or this is problem with the environment, and it's trying to be really challenging to identify where what the root cause is and how to actually address it. And if you have business logic that actually depends on these types and can also get really tricky to try to identify the root cause. So what can you do to make world just a better place in the next step? Well, you can use more Scala essentially. You can delegate some of these responsibilities of protecting your business layer to the whole development process with the compiler, and you can pull in some of the standard types that every version of Scala ships with. So if we refactor this code now, let's say that we introduce new functions. We introduce one function for actually reading the port. We introduce one function for reading the URL. And then we compose these functions together into a function that is responsible for reading the environment. Nothing really dramatic, but this means that if we get an error in some of these places, we will get some of the information back, and we will also get a way to make sure that the configuration is a bit safer, right? And this is kind of like level 2, how you can improve your configuration. We see in this case two examples of wrapping. We use option when a function can return a null, and we can also see the usage of either, which signals that either something can have a positive value or it fails with some kind of exception. In our case, it's throwable. And then somebody tries to actually use this application, runs it again. In this case, port is set, but the URL endpoint is misconfigured. For example, somebody, instead of putting the URL to the service we're calling, just wrongly put in a symbol X. And this means that the variable is set, it was passed along, but because X is not a protocol, at some point the system will crash, right? And this is obviously not really good and not sufficient enough to have to be sure that this thing is safe enough, right? So what's the next level then, right? The next level probably is to somehow introduce more context so that we know what exactly has crashed, where it has crashed, and how to know, like how to get better sense of what the error actually means, right? To do that, we commonly see that you can introduce your own class or your own set of objects that will kind of like wrap all the possible errors. In this case, we use Scala 3's anon type, and we identify, for example, all 3 possible errors that can happen. And because we extend the throwable, we also get all the information that the JVM carries around with exceptions, and we slightly adjust how these things are composed. And in this case, we now know that either this function will return configuration error or it will get a successful configuration. And we get more context and we have more descriptive errors. So if you rerun the example again, this time we will know that the endpoint URL is not set and that something else might be a problem, and what exactly it is, it will be written very explicitly. So, but we still have the problem that, for example, if somebody has mistyped the URL, you will still have the problem, right? So the question is, what more can you do? And the other example is that, for example, we were expecting ports, right? and port cannot be a negative number in regular operating systems. So that, for example, can also be a problem. And that again will clash, not this example, but if you're running some other service that, for example, randomly picks port numbers or something, that can be a problem. And how can you improve beyond that, right? The possible solution is that you just need to handle more cases. You need to think about how can you limit the scope of what are possible and good values and what are not acceptable values. And to do that, you can introduce additional conditions to your logic. So in this case, the configuration for reading the port gets additional condition where we specify that the port needs to be a positive number and needs to be less than 10,000. Nothing really dramatic, but it just means that additional rules were manually added to your validation, which means that more code was manually written to support your rules. And it also means that if you mistype some of these things, you might have problems. And more code means more maintenance down the road as well, right? And if we now run this example, you will get an exception like this, which means that the port was negative, and that's not really acceptable. Okay, what's the level beyond that, right? At some point, you can start thinking outside of the regular Scala libraries, outside of the standard libraries, and perhaps you can look into what, for example, CATS offers or Zio. And to improve your validation with CATS, you can do something like this. Here, we will pull in the Scala CATS library, and we will also use the refined types. And these two improvements mean that now instead of just saying that the URL is a regular string, we say that this URL is now a refined type of type string, and the port number is also not a regular number, but it's now a range that has to be between 0 and 9999. And this additional information, if you pass it along like this, means that you can also call additional functions that will extract this information out of type and do validation. So for example, in this case, we use then function refine v and the type, and it will try to try to refine the integer into a valid port type. And for example, refine v on the URL would also try to refine URL. This stuff, this refine functions return either, and that can nicely fit into your regular Scala code. And given that we now introduced CATS into our system, we can also reap the benefits of using the concurrence and parallel functionality. So for example, if you're doing the validation with CATS like this, you can also call PAR-map-n, which will do the validation that's written like this in parallel, which means that multiple conditions will be checked as well. And if we run the example again, you will see that we get, again, exception, but this time you get a bit more cryptic exceptions that are being compiled together by refined types and the system below it. And this is very positive, and it's a very good step in the right direction. So, okay, what's the step beyond that? And if we go into the more Zio ecosystem with all this stuff, in Zio world, you can do the next level probably if you use Zio Prelude. Zio Prelude is like a collection of libraries that will kind of like help you do Scala on a bit better level, I would say. And one of the packages within Prelude is called validation, and it's very similar as in CATS validated. And as you can see, the example on the surface looks very similar to what we had before. But in this case, we don't use the either type anymore. We use the validation type that has left side, which is kind of like the exception side, where you identify what's the error gonna be. On the right side, you define what's the positive value gonna be. And then you use these functions, for example, fail, from either, from option, etc. And you compose validation like this. And like I said earlier, with refined types, you can also mix these things together. So validation and refine mixed together will mean that you define the types, and then zero prelude validation will actually try to stitch these things together. So in this case, we also have validation from the environment, and both conditions from either from endpoint URL and port are going to be executed. And if something is wrong, we will also get back the error, and we can then react to that. So if we run this example again, you also see that I have a missing key endpoint because it was not set as a value. And you also see that the port number, for example, was misconfigured. So the idea is that if you use these types and if you just use these thin wrappers for validation, you can kind of like delegate a lot of these responsibilities to compiler, and macros that come with these libraries will try to give you much better safety through that. And if you use more types, if you use more of these refined types, you will find that you can do things like this. So for example, we defined the port range that needs to be within a specific number, but you can also go deeper than that. So for example, we say that the validation URL needs to start with HTTPS. So if somebody would put HTTP, this system will fail and it will give you an error out of that. You can do these kind of sophisticated type rules on collections. You can do it on generics, booleans, sequences, etc. So you can do a lot of very nice modeling of how strict these types should be. And a lot of them are already presets. So for example, for emails, etc., you can also just reuse a lot of those. And yeah, it just means that you need to define types better, and the rest is pretty trivial. If you rerun this example, so for example, you can see that I missed that I didn't configure the HTTPS, and I get exception like this because the rules were not actually met. Okay, so some of the summaries. Please look into the refined library. It's a beautiful library. It works with Scala 2 and Scala 3, and it will like easily it will make your application safer, and you won't drag so much problems inside your main core. Delegate some of this work to the compiler so that you won't have so much problems in the runtime. If you're coming from the zero world, please consider using prelude with validation. If you're coming from cats, check the validated, and please think about your application as this big onion and build it in layers and make sure that the outer layer is more safer. Now I only have 2 more minutes to spare, so I have 2 bonus slides here as well. One is if you're using Zio, there is a library called Zio config that gives you ability to compose these configurations very easily. Zio config by default is not dependent on refined. If you don't want that refined in your code base, then you can do something like this. So for example, my configuration is composed with an endpoint URL and port. And then I have also a way of either reading this configuration from the environment, or it can be from files, or it can be something else altogether. So in order to achieve this thing, in my case, only need like 2 lines. And this is going to be probably my last slide. if you also use refined already, you can also use xioconfig Magnolia library. And xioconfig Magnolia will essentially give you this derived config, and it will try to build all the things that I was talking about today, and derive it out of this case class that I defined here. So you can see that it it uses the refined types, and it will actually fit with the rest of the xioconfig ecosystem. So as you can see here, the right config and and refined is all you need to make these things even better. And if you run this thing, yeah, it all nicely and neatly works. And yeah, that's my talk for today.